Hi guys, let's solve a quick question on the continuity equation. The question is the average volume flow rate of a public water supply is 0.03 cubic meters per minute. What diameter of pipe should a plumber install in a shower fitting to get an exit velocity of 1.6 meters per second? And how much water will this fitting produce per second? Take the density of water to be 1000 kilograms per cubic meter. Okay, so over here we have the data that was given in the question. We have our volume flow rate, which is 0.3 cubic meters per minute. We have the exit velocity we're looking for to be 1.6 meters per second, and we're given the density of water. But you notice that the volume flow rate is given in per minute while we have our velocity in per second. So why don't we convert this quickly so that we can have units that agree with each other. So our volume flow rate here is 0.03 cubic meters per minute, and we know that 1 minute has 60 seconds in it. This will cancel this out here, and when we divide this and this, we have our volume flow rate to be 0.005 cubic meters per second, right? So now we can use this in our equations, right? So we know that volume flow rate is equal to the cross-sectional area multiplied by the velocity. Now what are we looking for here? We're looking for the diameter of pipe that the plumber should install, and that will be found when we expand the cross-sectional area. So let's make that the subject of this equation here. Cross-sectional area we should have is equal to volume flow rate divided by this velocity, right? So this should be equal to 0.005 cubic meters per second divided by 1.6 meters per second. So these cancel out here, and we get the cross-sectional area of this pipe should be 0.003125 square meters, right? So from there we should be able to start solving for the diameter of the pipe. We know that A is equal to 0.003125 meters per second, and is also equal to pi d squared over 4, right? So let us take this part. We want to make d the subject of the formula, and what we have is d is equal to square root of 4 times a over pi. Okay, so now let us put all this in the equation here. Let's expand that. So as we said d is equal to the square root of 4a, let's just make that clear, 4 times a over pi, right? So square root of 4 times 0.003125 over 3.14142. Okay, all right, let's use that value for pi, and we'll get the diameter of this pipe should be just about 0.02 meters, which is about 2 centimeters. Okay, so we've answered the first part of the question. We know the diameter of pipe that the plumber should install to get that exit velocity. The second part is much easier. It asks us how much water would this shower be releasing per second, okay? And we're told the density of water. So what is actually asking us is the mass flow rate here. So we know that mass flow rate Q is equal to density multiplied by volume flow rate. It's that simple. So all we have to do is 1000 kilogram per cubic meter multiplied by what was our volume flow rate, we said is 0.005 cubic meters per second. This cancels this out, okay, and that leaves us with 5 kilograms per second. Okay, so this is how much water the shower would release. It's a lot of water. I'm sure you don't need this much water for a shower, but you definitely need to know how to solve this kind of question. Take care and bye for now.